Okay, thank you, Charles, for the introduction. I think it gets started, and maybe meanwhile people start coming in. I'm going to talk about our journey towards circularity that we are having in our company. This journey started over 65 years ago when our fiber was invented, back in the days. And since then, we have been reinvented ourselves, reinvented the way we make our products, feed the industry with innovations, and I would like to share with you, to be part of our journey, some of our experience and results that we are having. Okay, this should move on. Okay, since LYCRA was invented, it was kind of a revolution in the textile industry. The level of comfort and changes that the presence of elastified fabrics and stretch fabrics has brought is something that nobody wants to give up anymore. So, and the one big motivation for the industry to change and to adapt in order to start using elastic fiber like LYCRA fiber, the one motivation is consumer demand and consumer benefit, because it's the consumer who wants these. And although using LYCRA fiber sometimes is difficult, we have to invent covering process step, for example. We need to have special yarn feeder. We need to have special this and that. But still, the fact that the consumer wants it at the end is the driver for the industry to adapt and find solutions so that we can deliver these at the end. Now, LYCRA fiber is a very complex product with a lot of technical aspect. Think about a LYCRA bobbin, 450 grams, 17 DTEX. You unwind it here. By the time you are in Stuttgart, you still have not finished that one bobbin of 400 grams. But the nice thing of LYCRA fiber, it stretches 5 times. So when you stretch this fiber from Stuttgart, you get to Barcelona with this one bobbin of 450 grams, which is quite neat. And the nice thing is that it doesn't only stretch, it goes back. So you're back to Stuttgart. And to make these in a uniform way with all the attributes that are needed is not easy. And to put on top all these sustainable attributes is another challenge that we are facing, and we are trying to solve with some of our solutions. So what we bring into the product is comfort, is stretch, is the fit that lasts, which equals to high performance. And we try to do that in the best way to preserve our environment. Okay, today is necessary when we talk about sustainability and circularity to ground ourselves on the legislation, which is really evolving, but is going to take over very soon. And the most important element here for us is the European strategy for sustainable and circular textiles. Okay, it's interesting now to review the objectives of this strategy. The strategy implements the commitments of the European Green Deal and the Circular Economy Action Plans, and it looks at the full life cycle of products, in this case textile products, from the way they are conceived, the way they are consumed, and eventually the way they are disposed and entering their end of life. And it provides a number of metrics or attributes that this product needs to have in order to have the lowest impact as possible on the environment. So there is a vision for the products that will be placed in the European community. They need to be durable products, possibly reusable, repairable, made out of recycled material, recyclable at the end of life, not containing any substances of hazard, and produced in a way that they respect the social rights. Okay? This is for the product. And then there is the consumer. The consumer is supposed to be protected by this regulation that is coming. And the way it is protected is by empowering the choices of the consumer, giving the tools and the information with transparencies on how the products are made, so that eventually products are durable, affordable, and of high quality. So this is the vision. Practice like reuse and repair are supposed to be now sponsored and privileged versus practice like landfilling or incineration. And these should be achieved not at the expense of the consumer, whether that means price, functionality, or comfort. So this is the strategy itself. And then the strategy develops in different ways. There are regulations, there are directives, and different actions that the European community is taking in order to make this more precise. And the ones that is very relevant for us, the biggest example is the eco-design for sustainable product regulation, so what we call ESPR. ESPR is the framework that comes from the strategy that passed into law in 2024. And now the European Parliament has delegated the European community to provide all the details into a delegated act. And there is this entity, which is the Joint Research Center, JRC, that through the assessment of this JRC, we will have all the details of the delegated act that will tell us all the metrics and all the things that at the end of the day will substantially change the way products are designed, are made, the way material are selected, and the performance they need to have. So things like renewable material, recycled material will be a more sustainable base to build up on our product. And for the consumer, the empowerment for the consumer comes with the digital product passport, which is a tool that will collect all the social information, all the information of the value chain of a certain product that will need to be collected in this digital passport tool that will make the consumer conscious of its choice and would be more easy to compare one product versus another. So that's it. It's going to be very complex. The delegated act is expected to be completed this year, and we look forward to understand the details of it. For sure, it will contain requirements in durability, requirements in recycled content, in recyclability, and exactly what it means and how the product needs to look like. A second very important part of the strategy is the Waste Framework Directive. This is a directive, it's not a regulation. So the regulation is a law. When it is passed and approved, it becomes a law in every state member. Instead, the directive is released by European Community, and each member state has to take the directive and transform into a local law, which is valid at the local level. And the review and the update of the Waste Framework Directive is now completed. There is an agreement between the European Council and the Parliament, and this should be approved sometimes in Q2 this year. So we will have the details of this package as well. The one pillar of the Waste Framework Directive is making the industry responsible for the cost and for the management of the waste that are created during the full life cycle of a product. So basically, we are moving the responsibility from the civil society to the producer of the waste. And these, and we don't have yet the details, but these will come with what are called eco-modulation fees. And the eco-modulation fees will be fees attached to each product, and we don't know yet if this is based on the weight or on the number of items, etc. So we don't have the details yet, but each product will be associated with a modulated fee, and the fee is going to be lower for those products that meet the criteria of the eco-design. So again, product with renewable content, product with recycled content, products that are very durable, repairable, will likely have lower fees than products that don't satisfy these criteria. It's very complex, but this is the environment where we are working with. It is evolving. We are trying to learn. But I thought it was interesting to ground everybody in this context, because this is where we have to work. Everybody as an industry, not only the LYCRA company. So what do we do? Far before the European Green Deal was conceived, we have created the Planet Agenda. Planet Agenda is not a project for us. It's the framework where we operate. It's really integral to the way we make business. It is divided in three big pillars. Okay? One is corporate responsibility. Corporate responsibility is about the fair and ethical treatment we have with our employees, our colleagues, and with the local community where we operate, so that we are an employer of choice. Then there is manufacturing excellence, and this is all about the way we consume and the conscious use of the way we consume resources, whether it is material, energy, land. So this is about energy saving in our plants, changing the source of the energy for running our plants, the carbon footprint of our product, etc. And then the last part, which is more relevant for my talking today, is product sustainability. And so all those attributes at the product level that goes towards sustainability. Raw material selection, replacement from fossil fuel to renewable sources, product stewardship, recyclability, all these kind of attributes. Okay, together with the Planet Agenda, we have a product vision. So this is the way, since few years now, we are envisioning our product, and this is the way we want our product to be in the future. It starts all from the way the raw material are selected. So there is a big effort from switching our base raw material from fossil-based to renewable sources. And by doing that, we are going to reduce significantly the carbon footprint and the emission associated to our product. And then there is the life of the product, which is probably one of the most important things. The longer our product lasts into the cycle, then the more sustainable it is, because there is no need to replace it with new items and with new products. And we have dedicated offering for each of our segment, of each of the textile segment that we serve. Chris Williams in the panel discussion before has touched quite a bit on swimwear and how chlorine resistance and attributes like that makes LYCRA fiber a key ingredient to extend the life of product for swimwear, but we have equivalent offering in other segments like legwear with product for run-resistant hosiery, or in intimate apparel with lasting fit and with all in denim. So in all of our segments, we have offering that really target the extended life of the final product through the use of LYCRA products that are dedicated for such segment. So after that, then we need to find some solution for the end of life, which is the most tricky part now. And this is again part of something that I'm going to disclose in the talk today. Okay. So this is the first part of the product vision then. How do we change our raw material from oil, from fossil to renewable? And this is our flagship product now that we are showcasing, and is going to be commercial. It's going to be produced at commercial scale this year, and it was quite a journey to get to this point today. So we are very proud where we are today. And what we have done with this product that we call bio-derived LYCRA eco-made fiber is replacing one very important ingredient for making our fiber, which is glycol, that accounts for about 70% of our composition. That traditionally, this is taken from the oil industry, from fossil resources. we can get exactly the same product, the same chemistry, not from fossil-based, but from agriculture. So something that is renewable. And by doing this, our LCA studies has already proved that we can decrease the carbon footprint of the full product as high as 44%. So by changing the source of one ingredient, not changing the way we make the product, but the source of that ingredient, we can reduce of almost half the carbon emission associated with the product, which is huge. This is very interesting because this can go to scale. So this is not a pilot project. This is a commercial project. The benefits are going to be for us, for the environment, but also for our customers, because this is going to help all the value chain to achieve the sustainability targets when LYCRA fiber is used. And then the performance, which are exactly identical to the incumbent product, because it's not a change on the chemistry, it's just a change on the way this chemistry is generated. Now, I try to explain in an easy way how we get from corn, so from a field, into LYCRA fiber, and then into a fabric. So this ingredient that I called, it's a glycol. Glycol itself is a polymer. I don't know how much details you want to know about that, but this polymer is made out of a monomer, and this monomer is called 1,4-butanediol, 1,4-BDO. Rather easy. So we take BDO, we make a polymer, and then we make our fiber. So this BDO comes from oil, or can come from fermentation of the dextrose, of the sugars, that are extracted from corn, and this is the way we are taking. So this is a very special type of corn that is grown in the United States. It's industrial corn. This is not meant for human eating, so it's not suitable for eating. It is grown today for industrial purposes, and it is used today for industrial purposes, not for making LYCRA fiber today. So this corn is used for extract the protein for animal feed, extract oil, extract the starch for making things like bioethanol or other fermentation product that goes in fuels or in other industrial application. The way this corn is made, first is this made in Iowa, which is in the US, in a very rainy part of the US, where there is no need of extra irrigation, so the fields are not irrigated. And there are in place a number of practices that are called regenerative agriculture that preserve the soil and makes these farms prosper in this so-called corn belt, which is this big area in the United States where corn is grown for industrial purpose. So we are taking the corn that today is going to bioethanol and fuel for automotives, and we are making a more precious material, which is LYCRA fiber for stretch fabrics. And there are a number. This corn is not for human consumption. There is very low or no irrigation to grow with, and there are practices of regenerative agriculture like no-till or low-till, cover crop rotation with soybeans, cover practice with rail, and this is to make everything prosper because this corn is collected by these big farms all around that are in a radius of about 100 miles from the plant. This is going to be processed, and everything has to be done in a very nice way because the land that is used for making these is very precious for the farms themselves. So again, this is how we take from corn to fabric. Again, I want to say the kernel of the kernel, one single kernel of corn is made out different material. We are interested into the starchy part, the carbohydrate part that account for about 60%. Then there is about 20% of protein, about 15% of moisture, and 5% or so of oil that goes into corn oil industry. The starch is the sugar. So the starch can be converted into glucose. Glucose is fermented through a fermentation process into BDO, And BDO is exactly the same molecule that we would have taken from fossil resources. So the truck that comes into our factory is the same truck carrying the same polymer. There is no difference into the product that we are going to make. The big difference is where this chemistry is generated, either in the ground, in the field from corn, or drilling a hole in the ground and taking oil. And we are very proud because this has reached a scale that, that makes this a commercial offering possible from this year. The project has started years ago, and now in 2025 is the year where this plant that you are seeing in the picture is going to be completed, and it will start to feed BDO to the value chain and eventually the polymer for us to making LYCRA fiber. It's a 65 kiloton plant. That means that we can start converting large part of our production into the renewable version of LYCRA fiber without giving up in any performance. Now, if you have read all the slides, you have seen names like Kira, Core. So we have business relation with company. It's a joint venture which is called Core that is running this plant. And the product has a brand name that is Kira. So Kira is the product, Core is the company we have the business with, and we are LYCRA who are going to use Kira BDO to make the eco-made bio-derived LYCRA fiber. The plant itself works on wind power mostly, and as I said before, all the corn comes from a very close area in order to make the impact all around sustainable. So, renewable offering at large scale, reduction of emission, 44% lower carbon emission, and same performance. And we are happy also to share that our business partner here for the launch of the bio-derived LYCRA eco-made product, Carvico, is showcasing some of their fabrics. Vita Life is called the fabric. So if you want to see how bio-derived LYCRA works, you can go to Carvico's booth and see this fabric and touch it and feel it. So we're very proud of that as well. Now, I'm going to switch gears and moving from renewable LYCRA fiber to the end of our product vision, which is end-of-life solution for LYCRA fibers. We have discussed already what we can do to enhance or reduce the footprint when we make it. And now let's see what we can do when this has reached the end of life. There is a perception in the market, especially in recycling of textiles, that elastane or spandex is an impediment for recycling. And this is unfortunate for us, especially because it's not always true, and it's not necessarily the case. It really depends how these processes are led and how LYCRA fiber is considered by the recyclers, if it is considered a waste or if it is considered a resource to be utilized and leveraged. Now, today, things like mechanical recycling can accept product with very low amount of spandex, 1, 2, 3, 4, 5% of LYCRA fiber can be accepted in mechanical recycling. Product with a higher amount of LYCRA fiber, say 10%, can go in things like automotive paddings, insulations, things like that, which represent indeed a downcycling. For product with higher amount or higher content of spandex, then it's even more challenging because there is not really a home today. So this is a challenge for the value chain that we want to understand, and this is where we are working now is, can spandex be separated from hard fiber at the end of life? Is it true that this is a big problem that cannot be separated? There are technology that can use these and make it valuable at the end of life. And then, if this is separated and we receive it back as secondary raw material, does it still have the value for us to be transformed back into LYCRA fiber? So, this is what I'm trying to cover now, and it's a challenge for us who deals with LYCRA fiber, but for the full value chain that has to handle stretch product and product elastified with elastomers. Unfortunately, the majority of recycling technologies has always focused on one single ingredient, the hard fiber, whether it is polyester, cotton, cellulosics, polyamide. These technologies targets the big portion they want to look and sort of neglect the existence of elastomer in the composition of the feedstock material that they are going to get. So this is a problem because in the process design, elastomers and spandex sometimes are not considered. And this represents the problem because if you design a process that does not fit the reality of the composition of the waste of textile that are around, then you will not be able to consume or to use that feedstock for feeding your recycling process. And we know spandex is around, so you cannot just say that I want to work only with 100% polyester or 100% nylon or 100% cotton, because that's not the reality of the textile waste that are around. So the value of spandex is somehow overlooked in its importance. Mechanical recycling, we said, can accept the presence of spandex at a certain level. Other techniques like chemical recycling, where there is a real depolymerization of the hard fiber into monomers. Depending on how this reaction is led, the presence of spandex can be tolerated more or less. But the point is, at the end of this, what I get out, okay, it's recycled polyester, but what I get out from the other side is spandex that I can still utilize. So we believe that the most successful recycling technology are those who already embed in their design at the beginning that elastomer exists, elastomer will feed their process, and there is a very high intrinsic chemical value associated to this fiber that we should not lose and consider a waste. If we look at the cost of raw material to make elastomers or cost of the raw material to make polyester, you probably end up saying that in fabrics, 80% polyester, 20% spandex, the value is in the spandex, it's not in the polyester, because of the value of the chemical value that is in this 20% part. Okay, what did we do? We have tried to qualify different recycling technology that we think are going to be successful because they are going to accept or yes, they are going to accept products that contain elastomers. So we have knit fabrics in our laboratories, or we have taken commercial products, commercial fabrics from the industry, dyed and finished, so perfect commercial products. We gave them to selected recyclers, those working with polyamides, those working with polyester, those working with cellulosic, and say, look, work with that, apply your process, and give back what you separate out of it, so that we can assess whether LYCRA fiber is usable or not for us. In most of the case, it's a positive answer. So in most of the case, LYCRA is considered, or spandex is considered a problem just because it's not considered as a precious raw material. But when we start to think that this has a lot of value, then these technologies start to understand that they rather consider a new product instead of a waste to be incinerated at the end of the process. So we take this back to our labs. Of course, it doesn't look like anymore as a virgin material, but we can apply our technologies, our recycling technology, put back into our solutions, mix with virgin polymers, and make recycled LYCRA fiber out of it. And this cannot happen at a large scale for the only reason that there is no large-scale supply of secondary spandex. If there was available secondary raw material for us, we would have commercial quantities of recycled LYCRA fiber. The performance of these can be sometimes a trade-off, but not always. So in this case, in this plot, I show a very typical plot that we use. It's called stress and strain plot, where you stretch the fiber and you measure the force you need to stretch, and then the fiber goes back and you measure the force that is given back out of this exercise. And you see the red and the yellow cores, which overlaps quite well, where the yellow is a fiber made with 33% of spandex recycled from end-of-life fabrics. And okay, you can compare the properties. These are quite nice. This is coming from the lab. It's not coming from commercial production for the reason that I said before. But the message is we can recycle lycra fiber. We can do it. We are committed to that. But we need to build the value chain so that we can get to this raw material to make recycled lycra fiber at the end. There's some pictures of the product that we have made. So the achievement is recycling fabrics that contains lycra fiber is possible. It's not necessarily an impediment. Those who say that lycra fiber is a problem in recycling technology are those who have not accounted for the existence of lycra fiber. We have done successful trial up to 50% recycled content while remaking lycra fiber from recycled end-of-life products. There is a scale limit that I have already discussed. But the recycling process itself can benefit a lot by recognizing of this value, because all in a sudden, the recycler has another very valuable product to deliver back to us, for example, to be used. And this is not anymore a waste to handle, but is a precious product that makes benefits. So wrapping up a bit what I've said, we are working quite closely with recyclers under NDAs to validate those technology who can accept elastified products and can deliver back secondary raw material that is suitable for respinning and making new recycled fiber. We focus on a variety of processes, which is, we're not interested whether it is polyester, polyamide, cellulosic. We need lycra fiber back to us so that we can transform back into fiber. It's a long journey. It's a long-term initiative, because today we can collect kilograms of these. We need kilotons of these. But it's a step-by-step approach, and it's an interesting journey, and we are very much committed to do that. We think there is no alternative to find this sort of solution. It's not easy, but it's possible. And we are very proud to where we are. So we are all in this journey. And I hope by this experience you will be supporting in that, and you can share some of this path together.
Now's your opportunity. We've got Alberto. He's a mine of information. If you don't ask him questions, I ask him questions. And Alberto, you should relax, because Chris, you thought I asked the hardest question too earlier. He's been feeding me with ones that will really annoy you. You've got the wisdom out of the R&D who has seen the future of stretch. Is there anything you want to ask him? If you don't want to ask him publicly, I will make sure he stands by the stage afterwards and answers the questions. But the first question is,
thank you for the presentation. I have actually two questions. First one is about the renewable resources that LYCRA is made of. I can understand that from the corn, the polyester portion of polymer can be generated, but it's impressive if the polyurethane part, like elastic part, can be generated from the renewable resources. Can you clarify, explain a little bit about that? Super stretch, how that is acquired by the corn?
Yes, sure. So our fiber is made of two elements. One we call a soft segment, is the one that delivers the stretch, and the other we call hard segment. That is the hard domains that gives the mechanical properties. So we are finding a new source for the soft segment, which is a polymer itself. It's a glycol. This polymer is made out of a monomer that is called BDO, butanediol. Okay, so this very molecule can come from oil or can come from fermentation. So we get BDO, we polymerize into our glycol, which is our soft segment, and this soft segment, together with the hard segment, makes lycra fiber. Does it make sense?
Yes, yes. Thank you very much for an extra explanation. The second question is about recycling the lycra. And I think the core technology for recycling lycra is the technology that separates lycra polymer from the blended other fiber. Can you explain a little bit more what kind of process it is? Is it like chemical process or physical process, biological process?
So we are working under NDAs with recyclers, so we do not own the textile recycling part, but we work with the recyclers so that we understand what they are doing and the material that we receive is usable for us. So the recycling process can be is usually a chemical process that depolymerizes the hard fiber. So the process that are more friend with lycra fiber are those in which this depolymerization happen without destroying the chemistry of lycra fiber. So you remove polyester, for example, back into glycol and TPA, and lycra fiber is not touched. So you dissolve one and you keep the other in a so-called solid form. An alternative is you dissolve or depolymerize the lycra part and you keep the rest solid and you separate in a different way. So there are different means. Many can be successful. For us, it's not important which type of process is used as far as the polymer that we are interested in is not destroyed.
One question concerning your spinning technologies, because
Concerning, sorry?
spinning technologies, because in normal production of elastane, you would use DMF as for the solution spinning. So do you still need that? Because this is prohibited in the European Union. So
yes, we don't need it because we have never used DMF in our production.
So how do you spin? It's a melt spinning process, or what would it be?
We use another solvent which is not DMF.
Ah, all right. Okay.
Very professional answer. Thank you. It's look, I'm still looking for more questions. I want to make sure that Alberto has a hard time on stage. He is a source of information. If you really have nothing better to do, spend it with Alberto. What they are up to at the LYCRA Company will blow your mind. What they're trying to do, how they're approaching it. There's innovation just coming out all areas. Some works, a lot fails, but you are achieving more than anyone else at the moment, so full credit. It's what we need, the innovation within the industry. I'm still filling, because I'm looking for people with questions. But I think you're going to be able to get away, Albert. Can I ask you once again to show your appreciation for Alberto?
Thank you. Thank you, Charles.